Hi guys. Okay, so today we're gonna solve logarithms. Basically, the steps are here at the top. Number one, it's to condense each logarithm. That means get it into its simplest form. Make sure only one log is on the left, one log is on the right. Then we're going to use the one-to-one property. Basically, the one-to-one property states that if you have two logs of the same base and they're set equal to each other, you could drop the logs and just solve both of the a's for a variable. The last step, one of the most important steps, is always check for extraneous solutions. So if it does not work out, if both sides are not equal to each other, or if we have a negative log, it is not a solution. We cannot have negative logs, and they have to be equal to each other to be able to call it a solution. So let's start super basic. Let's start with number one. The first thing that I look for in my two logs are my bases the same? In this case, the log on the left, the base is 5. The log on the right, the base is 5. So they are the same. We could use the one-to-one property, which we're going to drop the bases because they're the same. And we're just going to set both of the a's equal to each other. And then we solve for that variable. So in this case, we're going to solve for x. So I would subtract 5x to both sides. On the left, I'm left with a 9. On the right, I'm left with 1x, or just x, right? And this could be a possible solution. I say possible because you have to check, don't forget. So plug the 9 that we got for x back into the original equation. Later on, when we simplify logs, then you can plug it into the simplified equation. But we did not simplify this log because this is a basic one, right? Okay, so if I were to calculate this, right, I'm only calculating what's inside the parentheses. In this case, 5 times 9 is 45, plus 9 is 64. So that gives me log base 5 of 64. Is that equal to log base 5 of 6 times 9? Yes, because 6 times 9 is also 64. See how both the left and the right sides are both exactly the same? Therefore, I could say that yes, 9 is a solution. So we're good. Okay, let's move on to number 3. So number 3, I have log base 9. So look at your bases. Are the bases on the left the same as the base on the right? Yes. Do I just have one log on the left and one log on the right? Yeah, they're in the most simplified form. So let's drop the logs and let's just bring down our a's. Our a's are 6 minus 3w, and on the other side, negative 2w. And again, solve for the variable. In this case, we're solving for w. So I'm going to add 3w to both sides so that way I can cancel that on the left. And I'm left with 6 on the left is equal to negative 2 plus 3. Again, is just 1w, or w, right? This is a possible solution. I say possible again because you have to check. Don't forget, that's an important step. And you don't have to actually solve the log when you're checking. You're just checking to see if the numbers match up, right? The numbers inside the parentheses. We've been checking since the beginning of the school year, so you should be okay with checking by now. So this would give me log base 9 of 6 minus 18, which gives me a negative 12, which is equal to log base 9 of negative 2 times 6, which is negative 12. Even though both the left side and the right side are the same, you cannot have negative logs. You cannot have negative logs. Let me write that. No negative logs. Therefore, this 6 is not a solution. So if we don't have a solution, we're going to say this is no solution. Okay, because we cannot have negative logs. Even though they were the same on both sides, they were negative 12s, and we cannot have negative logs. Okay, let's talk about I guess we'll do number 4. Okay, let's talk about this one. Why do I want to talk about this one? Well, do we notice that we have two logarithms on the same side, on the left side of the equal sign? On the right side of the equal sign, I have one log, which is okay, but on the left, I need to condense. So we're going to look at the property of addition. If you remember your properties, addition is part of the product property. To condense an addition logarithm function, what we're going to have to do is we're actually going to have to multiply, right? So this is part of the product, let me write it for you, product property, where we go from multiplying to addition or addition to multiplying, right? Okay, so that means to condense the left side, I'm going to take the log. If you don't see a base, you know it's base A, right? Okay, so I'm going to take the log of y plus 5, and I'm going to multiply that by the other log on that left side, which is 4. On the right side, log of 72 can stay just as is, right? Because there's only one log on the right side. Okay, let's condense it even more, right? We can bring this 4 inside the inside the parentheses, distribute, right? So this actually gives me log 4y plus 20, because 4 times 5 is 20, is equal to log of 72. Okay, now I just have one log on the left, one log on the right. This is what I mean by condensing. So now I check, are my bases the same? Yes, because we know that these are base 10, yeah? So drop the logs and bring down your a's. 4y plus 20 is equal to 72. Solve for y. So minus 20, that gives me 4y is equal to 52. Divide both sides by 4. And that gives me y is equal to 13. Okay, now you can plug the log, and I'll do it up here, the space on top. So this is a possible solution, right? Let's double check if it truly is a solution. So we're going to plug it in, and this is what I said when you can go back in the simplified log. You know how we simplified it up here when we condensed it? Why don't we use that instead of the original log, right? Let's use a condensed log. It's just going to be so much easier. And plug in 13. Let's see if that is true, if that solution is true. So up here at the very top, I'm going to plug in 13 log of 72. So basically we want to see is the left side 72. So 4 times 13 plus 20, putting that in my calculator right here. Yep, gives me 72. Log of 72 is equal to log of 72, right? Both sides are equal to each other. They're the same. There's no negative log. So yeah, this is true. Therefore, 13 is my solution. Okay, hopefully we're getting the hang of it, right? Let's talk about number 7, because number 7 has something different. So on number 7, I have this 1/2 that's in the front, right? So anytime you have a number in front of a log, don't start trying to drop the log. You can't drop the logs until the logs are by themselves on both sides of the equation. In this case, the log is not by itself because it has a 1/2 in front of it. It has a coefficient in front of it. So, do you guys remember the power property? The power property states that if you have a number in front of a log, you get to bring that number as a power, as an exponent to the top, right? So let's bring this 1/2 to the top of 25. Don't change it, don't make it negative, don't do anything crazy. Just bring the 1/2 to the top. So this gives me log base 6 of 25 to the 1/2. See how I bring them to the top? And on the other side, we're good, right? Okay, are my bases the same now? Yes. So I could drop these logs, right? Because the logs are by themselves now, right? There's no numbers in front of the logs anymore because we brought it up as a power. Okay, bases are the same. Let's drop the logs. 25 to the 1/2 power, that's actually 5. 25 to the 1/2 power is 5. Set that equal to the other side, which I have 23 minus 4w, and let's solve for w, right? So let's subtract 23 first. Oops, wrong one. Okay, this gives me negative 18. It's equal to negative 4w. Let's divide both sides by negative 4. So w is equal to, I'm going to simplify this fraction, 9/2. Double check it, right? Why don't we use the simplified log, right? So let's double check it. So let me write it right here. So I'm going to double check log base 6 of, I know that that's 5, right? We said that 25 to the 1/2 power is 5. So I'm going to say log base 6 of 5 is equal to log base 6 of 23 minus 4w, but we are checking that w is 9 over 2. Okay, so let me write this. We're basically seeing if we get 5, we're good, right? Okay, so let me put this in the calculator. 23 minus 4 times 9 over 2. Okay, yes. Awesome. It is equal to 5. Therefore, both sides are the same, so this is truly my solution. Okay, let's talk about number 9. Yeah, number 9 is a good one. Why is number 9 a good one? Okay, so look, now we have m squared. We haven't said anything about these exponents yet, right? Except for the previous one that we did, we changed it to an exponent. But we haven't talked about when they just give us an exponent, variable squared in this case, right? Okay, so first off, check, are your bases the same? Yes. Are the logs, one log on the left, one log on the right by themselves? Yes, therefore we could drop the logs. Okay, so that brings us with m squared is equal to 18 minus 7m. Okay, anytime you guys have variable squared, x squared, m squared, a squared, anything that has a variable that is squared, it is a quadratic. And what I mean by that is quadratic equations are very particular. You have to have 0 on one side of the equation for to solve a quadratic equation. So what that means is I need to bring everything to one side. So here I have m squared plus 7m is equal to 18, right? These guys canceled. Okay, now bring the 18 over to the other side. So minus 18 minus 18. So that leaves me with m squared plus 7m minus 18 is equal to 0. See how I want it equal to 0? Why? Because to be able to solve a quadratic equation like this, you have to factor. What is factoring? X method. What we all love to do, right? X method. Okay, in X method, we have a times c at the top, therefore 1 times negative 18, which gives me negative 18. Then we have b at the bottom. In this case, our b is 7. Think of two numbers that multiply to negative 18, but add to 7. And that gives us positive 9 and negative 2. Because a is 1, you can just write your factors as m plus 9, m minus 2. I'm not going to explain factoring in this video because we should all know it by now, right? Okay, set each factor equal to 0. Therefore, m is equal to negative 9 and m is equal to 2. So I have two possible solutions here, but are they truly solutions? We have to check. We have to go back to the original logarithm, right? Because we didn't simplify this one, so we have to go back to the original one up here that I'm circling in green, plug negative 9 in for m, right? Check to see if they're both equal. Plug 2 in for m, check to see if they're both equal. If so, then both of them are my solution. If one of them doesn't check out, one of them's not a solution. If both of them don't equal to each other, then we don't have any solutions, right? No solution. So I'm checking, right? If I plug negative 9 into m squared, that gives me positive 81, and 18 minus 7 times negative 9 is positive 81, right? So negative 9, yes, is a solution. How about 2? If I plug in 2, m squared is 4. 18 minus 7 times 4, yep, also is 4. So yes, both of these check out, right? I checked them. I put them in the calculator, so yeah, both of them are my solution. Okay. Let's talk about the last scenario. So we have two types. Do you see on the left side it says type 2, log is equal to a number? So this whole time we've been talking about logs on both sides, right? And we were able to solve by dropping the log, right, if they have the same base. But what happens now if I have a log on just one side and it's equal to a number on the other side? Well, we have to transform this log to an exponential. So let me remind you, how would I transform a log? So if I have log base b of a is equal to x, right? Something like, look at number 11, right? That's in that form, log base b of a is equal to x. I can transform this to an exponential function by getting the b, the base, so I'm going to circle that in red, and making it a base in my exponential. My exponent will be the x that I have on the right side of the equation, of the original log equation, and I'm going to set that equal to the a, whatever the a is. Okay, that's how we change from log to exponential. So at number 11, right, log base 2 of x minus 4 is equal to 6. My base, my b, I'll circle it in the same color red. My base is 2 to the power of x. In this case, the x is the number on the right side, the 6, so 2 to the power 6. And set that equal to your a. Your a is what's in parentheses, x minus 4. Okay, 2 to the power of 6, let me put that in here, is 64. So I have 64 is equal to x minus 4 to solve. But to get x by itself, I just have to add 4 to both sides. And I have 68 is equal to x, right? You still have to check, is this a solution? So plug it back in, right? And in this case, let's see. To check if this is a solution, I'm gonna have to remind you of the change of base formula. Let me write that up here. Change of base formula. Basically, you take the log of a and you divide him by the log of your b. That's your change of base formula. Why am I telling you about this? Because now we no longer have two logs on the same side. So to be able to check to see if 68 is truly a solution, you have to use the change of base formula. Okay, so we have to take log of a. So log, remember our a is what's in parentheses. I'll put it in green for us. Log of x minus 4. And we have to put that over log of b. Our b, remember, is that base, which is 2. I'm checking, though, for x, okay? And we know we're also checking over here, is it equal to 6, right? 6 was on the right side. Okay, we need to see if log of x minus 4 over log of 2 is equal to 6. But we know we're checking log of x, right? So let me put x, which is 68 in blue, minus 4 over log of 2. Is that equal to 6? So put that in the calculator, right? If you put it in the calculator, remember, log without base is base 10. That's what your calculators are programmed to do. And yeah, look, I got 6. Did you get 6? So 6 is equal to 6, right? Therefore, this is a solution. Okay, let's do one more. Let's do number 13. Okay, on number 13, I have 2 logs on the same side, right? I only want 1. So how would I combine these two? Well, again, we talked about the product property. In this case, I have adding, which is product property, so I need to multiply my 2 a's, right? So this would give me log 2x times x minus 5, right, is equal to 2. I could simplify this a little more. Let me distribute the 2x inside the binomial right there. So this gives me log of 2x squared minus 10, because negative 5 times 2 is 10, x is equal to 2. Okay, now that I only have one log on the left, which is what I want, I'm going to use right here, changing it to an exponential. So I take the base. In this case, I don't see a base. Therefore, I'm going to assume it's my common base, base 10. So I have 10 to the power of x. In this case, x is the 2 that's on the other side of the equal sign. And set that equal to a. A is going to be what's in the parentheses. But see how we can only have one log on one side? Because if we have 2 logs, we really don't know what to do, right? We can't change it to exponential. Okay, so 10 squared. 10 squared gives me 100 is equal to 2x squared minus 10x. Did you guys see that x squared? We know this is a quadratic. Therefore, I have to move the 100 over to the other side. Because it needs to be equal to 0 to solve a quadratic, you have to equal it to 0. Okay, to solve a quadratic, do you guys remember? We have to, and you know what, I'm going to go into number 15, but I'm not going to do 15. I just need the space down here. So I'm going to X that out for right now, so that way we don't get confused. Okay, we need to factor it, right? Do you guys see something that you can take out? Something a greatest common factor perhaps? Like a 2, right? We could take out a 2. So divide everything by 2. Okay, now a is 1, which is great, so we could do the x method really nicely. If my a is 1, a times c is 1 times negative 50. That gives me negative 50 at the top, and b at the bottom, negative 5. Two numbers that multiply to get negative 50, but add to 5. Let's see, or to negative 5, I'm sorry. That would give me numbers like, I know 10 times 5 is 50. I need a negative 5, so negative 10 and positive 5, right? Negative 10 times positive 5 is negative 50. Negative 10 plus 5 is negative 5. Yep. But because we got a to be 1, we could just write our factors as is. We don't have to embed, right? Anything? We're setting those guys equal to 0. If you're asking what happened to the 2, right? If I set 2 equal to 0, that's not possible, so that's why I kind of got rid of the 2. I don't need that 2 anymore that I factored out. I'm just curious or just wanting to know about the solutions to the quadratic equation. So we can forget the 2 for now. Okay, so I say that x is equal to positive 10 and x is equal to negative 5, but is this true, right? Let's plug it back into the simplified equation. I'm going to circle it or box it out in yellow. That equation that I boxed out in yellow is my simplified one. Let's plug in both the 10 and the negative 5, and let's make sure that we get it equal to 2. Why 2? Because do you see that on the right side? It's equal to 2. Okay, so I'm going to put log of 2. We're going to check 10 first. 10 squared minus 10 times 10. Lots of 10s there. And let's make sure that's equal to 2. Let's simplify that a little. 2 times 10 squared minus 10 times 10. That's going to give me 200 log of 100, right? Because 10 squared is 100 times 2 is 200. 200 minus 10 times 10, which is 100, is 100, yeah. Okay, but how can I check this, right? Well, since it's base 10, actually, you could put it just in the calculator. So actually, let's do that. Let's put log, because we have base 10, right? This is my common base. This is the only base that you could put in the calculator. So just put log of 100, and that, yes, gives me 2. I checked it. So this one is checked out. Let's do the same thing for negative 5, right? So let's put log of 2, put that in blue, negative 5 squared minus 10, negative 5 equal to 2. Let's make sure that's equal to 2 as well. So that gives me log of 50, let's see, yeah, 25 times 2 is 50. 50 plus 50 is log of 100. And we already checked that, right? That does equal to 2. Yay! So negative 5 is also a solution. So we're good. This was number 13, I'm sorry. And our 2 solutions are good. We just checked them. Okay, if you guys have any questions, as always, I'm here before or after school, okay? Bye, guys.